Hey there, and welcome to week 2. I think you're probably finding right now that taking this class is almost a full-time job. So let's take a look at week 2 things to focus on. The second half of the week is going to be harder than the first half of the week. So the first half of the week is fairly simple, and most of it's review. Quadratic functions, find the roots using the quadratic formula. Now, quadratic formula is something you need to memorize. There aren't a lot of things you need to memorize in this course, but definitely quadratic formula is one of them. So x equals negative b plus or minus square root of b squared minus 4ac over 2a, and that gives you the roots of a quadratic function. Video 3 isn't too exciting, but I suggest you watch it. There are two authors of the videos. I like the Sousa videos better. This video is by the other author, and he's not that dynamic, but he gets the job done, so you should watch that. The vertex formula, x equals negative b over 2a. That will find the x-coordinate for the vertex of a quadratic function. Graph a parabola and write the equation in both standard form and general form and be able to go between the two forms. Those are videos 1, 2, 4, and 5. Polynomials, there are 10 videos to watch. I suggest you watch all of them. Put them on double speed if you have to, but they're very valuable. So let's just go over what you're going to learn about. End behavior, that's the behavior as x either goes to negative infinity or infinity of the polynomial. So this graph is going to go up to infinity on either side as x goes to infinity or negative infinity. Intercepts, both x and y. So these are x-intercepts. Down here, that's a y-intercept, x, x. Multiplicities of roots. So that's something super important. Here I've got a polynomial. It's got roots 1, negative 3, and 2. So those are the x-intercepts. And the multiplicities are the exponents over each factor. So the multiplicity here is a 1, you're just not seeing it. And this is a multiplicity 3. Now, why do we care? The multiplicity tells you whether the graph is going to cross the x-axis at the root or bounce back. If it's an odd multiplicity, like 1 and 3, you're going to cross. So we see graph crosses here, and then over here, graph crosses. But if it's an even multiplicity, like 2, the graph is going to bounce back. So that's what you're seeing there. It stays on one side of the x-axis. Long division, that's a review. I suggest you watch video 1. It's just a general introduction of how the process of long division works. Usually that's a problem for algebra students, so that might be worth your time. And then the other videos are specific examples of long division. So part 2, this is where you're really going to be spending the most time. Rational functions, all about rational functions is 3-7. So this is a fairly intense section. For a rational function, you want to be able to find the domain. Now that's going to be review because we've already talked about the domain of rational functions, and then writing the domain in both inequality and interval notation. And you want to be able to do both. And so I always suggest if you're trying to do interval notation and you have inequality notation, just make a graph. If x can't be 2 or 3, then those numbers get punched out and you're left with 3 intervals from negative infinity to 2, 2 to 3, 3 to infinity. Horizontal asymptotes and vertical asymptotes. Horizontal asymptotes have a set of rules associated with them, and those are reviewed in video 2. Vertical asymptotes are where the denominator of the rational function is 0. OAs, that stands for oblique asymptotes. You'll find those by using long division. Intercepts and holes, graphs, and finding equations from the graphs. Those are videos 6 and 7, and I definitely suggest watching those. Okay, 3-8 is just, again, this is review. It's more on inverses of radical and rational functions, and then the domains and ranges. I think you'll find the videos review, but sometimes review is good because it just solidifies your understanding. And then 3-10 and 3-11, those are going to be the longest sections. Polynomial inequalities. spend some time watching all of these videos. If you can understand polynomial inequalities, then section 311 will be easier, which is rational inequalities. So you want to be able to show your number line for an inequality and give your answer in both notations. Now, I'm going to want on tests to see your number line and see your work. So when you'll see this in video 3, the guidelines for solving polynomial inequalities. You're going to find the zeros and plot the critical numbers on a number line. So you'll have like maybe 2 and 3, and that will break your number line up into 3 intervals. And then you're going to choose a test point from each interval and test the inequality to see if it's true or false to decide which intervals go into your answer and which don't. Videos 4 and 5 are great because they review factoring by grouping. Well, actually, video 3 is factoring by grouping, which you need to be able to do. It's an important skill. And videos 4 and 5, just more review of factoring and factoring out the GCF. Now, rational inequalities work pretty much the same way, except they have an added level of complexity in that you've got a denominator now. Video 1 is an overview lesson. It's about 12 minutes, but I strongly suggest you watch it, and it's got really good examples of less than or equal to versus less than, or greater than or equal to versus greater than, and how that affects your answer. Videos 5 and 6 are super important. This problem here is video number 6, and it walks you through how to solve that inequality. And as you're watching that, you might say, hey, why is the author doing this? Why can't he just multiply both sides of this by x plus 2? Wouldn't that be quicker? Like that? And solve, and instead he's moving the 2 over, he's finding a common denominator, and you might think, gosh, that seems like a lot of work. Well, the problem with doing this, multiplying both sides by x plus 2, is when you multiply both sides of an inequality by a positive number, the inequality stays in the direction it's going in. But if you multiply both sides of an inequality by a negative number, then the inequality has to flip. Now, if you multiply both sides of this inequality by x plus 2, the problem is you have no idea whether x plus 2 is positive or negative. It will depend on what x is. So typically, you're not allowed to multiply an inequality by an expression involving a variable. And that's why you have to go through all of that work. All right, so have a great week. And that's the end of the summary.